Hi friends, good morning. So today we are going to see about electromagnetic wave equation. So we have to know what is the importance of wave equation. So in your electromagnetic field subject, in first two units we have studied about the electric field and its application. In the third and fourth unit we have studied about the magnetic field and its application. In fifth unit, we are seeing the relationship between electric field and magnetic field. So the relationship between the electric field and magnetic field, the main application is in the wave propagation. That is, main application will be in your wireless communication. Example will be your mobile, Wi-Fi, Bluetooth, anything which are free space communication. So how the waves are propagating in the free space is indicated in 3D diagram as shown in the first picture. So in as this picture, we are going to see the mathematical derivation of this equation so that we can transmit the useful information along the electromagnetic wave. So the wave equation and their solution, we are going to see about the two wave equations. One is the wave equation in free space. Second is the wave equation in the conducting medium. So wave equation in the free space. So free space is a simple, linear, isotropic and homogeneous non-conducting medium characterized by permittivity and permeability mu naught and epsilon naught equal to mu r and epsilon r equal to 1 and mu naught value will be equal to 4 pi into 10 power minus 7. Epsilon naught value will be equal to 8.854 into 10 power minus 12. Since this is a non-conducting medium, the conductivity parameter sigma will be equal to 0. So in the fourth unit, the first topic is the Maxwell's equation, which gives the relationship between electric field and magnetic field. Previously have studied the Maxwell's equation and Maxwell's equation for free space. So these are the four equations for Maxwell's equations for free space. So when you take the free space, we are applying the condition J is equal to 0. So J is your current density is equal to 0 and rho is your surface charge density or volume charge density will be equal to 0. So you will get the four equations. Del cross E is equal to minus mu dou H by dou T. Del cross H is equal to epsilon dou E by dou T. Del dot E is equal to 0. Why? Actual equation is del dot D is equal to rho V. D is equal to epsilon into E. So you will get del dot E is equal to rho V by epsilon. When you substitute rho is equal to 0, you will get del dot E is equal to 0. So another fourth Maxwell's equation is del dot D is equal to 0 or del dot H is equal to 0. So for wave equation, we have two wave equations. One is for electric field, other is for magnetic field. First, we will see for electric field. So in electric field, we will derive with the equation del cross E is equal to minus mu dou H by dou T. That's the first Maxwell's equation. Take the first Maxwell's equation and take curl on both the sides. So when you take del cross on both the sides, when you take del cross, you will get minus mu dou by dou T del cross H. So del cross H is given by the Maxwell's second equation. Del cross H is equal to epsilon dou E by dou T. That is equation 2. So now in the previous equation, substitute del cross H is equal to epsilon dou E by dou T. So after substituting, you can take epsilon outside since it is a constant. So you will get dou into dou square E by dou T square. It is the second order differential equation. After that, in the LHS, we have del cross E. So this can be expanded by the curl formula. We can write that as del dot E is equal to, del dot E minus del square E is equal to del cross E. We are using this formula. So after substituting this formula, we can go with the Maxwell's third equation. Maxwell's third equation is del dot E is equal to 0. So when you substitute the Maxwell's third equation, del dot E is equal to 0, we will get minus del square E. The first term will be 0. So minus del square E is equal to minus mu epsilon dou square E by dou T square. Both the side you have minus, so cancelled each other. So you will get del square E is equal to minus mu epsilon dou square E by dou T square. After that, take the RHS term to the LHS term. You will get dou square E minus epsilon mu dou square E divided by dou T square is equal to 0. And in this free space, epsilon R is equal to 0 and epsilon mu R is equal to 0. That is a condition for free space. So mu is equal to mu naught into mu R. Epsilon is equal to epsilon naught into epsilon R. Substitute mu R is and epsilon R is equal to 1. You will get mu can be replaced by mu naught and epsilon can be replaced by epsilon naught. So the end Maxwell's equation will be del square E is equal to minus mu naught epsilon naught dou square E by dou T square is equal to 0. So this is the wave equation derived from the Maxwell's equation. This is the wave equation for electric field intensity. Okay, so this is the first equation. Second, we will derive the wave equation for magnetic field, and this is same as the previous step. So you itself can similarly try first the previous step, but with the equation 2. What is the equation 2? Del cross H is equal to epsilon dou E by dou T. So at the first step, take curl on both the sides. After taking the curl, substitute the Maxwell's first equation, del cross E is equal to minus mu dou H by dou T. Take the constant term outside. You will get the equation minus mu epsilon dou square H by dou T square. Substitute the vector formula. And next substitute the Maxwell's fourth equation, del dot H is equal to 0. You will get the equation minus del square H is equal to minus mu epsilon dou square H by dou T square. Next substitute the formula, mu is equal to mu naught epsilon naught. Mu is equal to mu naught mu R. Epsilon is equal to epsilon naught epsilon R. Epsilon R and epsilon mu R is equal to 1. So you will get the final equation, del square H is minus mu naught epsilon naught dou square H by dou T square is equal to 0. So now we have derived the wave equation for electric field and magnetic field. So next we will meet in the video of wave equation for conducting medium. Thank you.